Hi, I'm Ian Horswill, and I'm here to talk about a system called Imaginarium, which is a casual PCG tool, a procedural content generation tool, for tabletop RPG games. It's primarily targeting game masters, although it can also be used by players. But the important thing is that we're assuming that the people who are writing generators for it are not trained as programmers. So following Nelson's work with Inform 7, it uses structured English for its declarative programming language. It's backed then by a satisfaction module theory solver that's randomized. SMT is like a SAT solver, but with some extra bells and whistles. It gives you an interactive environment where you can incrementally try things out and add constraints and remove them. And after it's generated a model, after it's generated a thing, it gives it back to you in English again, or for binary relations, it portrays them as it visualizes them as graphs. There's a long history of tabletop of generators being used in tabletop playing, dice-based generators. There are also a number of software systems for generating maps, generating characters, and so on. I'm not aware of any systems that do anything like constraint satisfaction, and not a lot of stuff that is intended to be kind of a powerful system that could be used by non-programmers. This work follows in the footsteps of a lot of great work on constraint-based PCG. I want to give particular shout-outs to Gillian Smith's Tanagra system and Adam Smith's work with answer set programming. And it's heavily influenced by the work that others have done on casual creators, especially Graham Nelson's work, as I mentioned before, but really especially Kate Compton's work on tracery and her very notion of the idea of a casual creator. So the goal here is to make something that will actually be used by people who aren't me, people who don't go to aid. And so we're trying to put a lot of work in to make it usable by other people. As a kind of initial pre-test, we haven't done a full user study yet, but just to see if it was even plausible to use it in a class, we taught a class last spring on AI and tabletop RPGs, and it did have a bunch of students in it who were like theater majors, creative writing majors, music majors, and so on. And all of those students did write their own generators, wrote unit tests for them, worked in groups to design games that integrated PCG into them, things like that. We did learn a lot about how to make the system more usable by people. We had to, do a lot more proactive error checking and things like that. But the happy news is that we didn't have to give up on it, which I wasn't going to be surprised if we did have to, but we didn't have to. So let's do a very quick demo of the system. Here it is. I'm going to show you two generators. I'm going to show you the cat generator that you'll see some code from later on. So we can say generate a bunch of cats. I press the 10 cats button, which just is the equivalent of entering down here, typing in imagine 10 cats. So it generates a bunch of cats here. It also generates relationship maps for them, so it knows that cats can love or hate each other. They can't both love and hate one another. And it knows that every cat should have at least 3 relationships with other cats. All right, that's the cat generator. Now let's just quickly look. Here's the fiasco generator. We can generate a bunch of characters and look at the characters who get generated. We've got Vicky is a parent of Adriana, who is a child, and she's friends with her friend Mead, and she doesn't get along with Juana Ridal, who's actually an adult. That's interesting. So there's a bunch of stuff there. Mead is apparently in Peter Thiel's secret bunker. And we can also get a visualization of the semantic net of the system. So I wish I had more time to show that off, but I don't. So let's go back to the talk slides. You can try it yourself. You can download it from GitHub. The thing to do first would be to try the GUI that I was just showing you, which is in Imaginarium. If you want to use it inside of your own game just as a generator, you can do that. You can download Imaginarium Core. But what you can do right now is the awesome Diana Smith has made a Discord bot out of it. And so we really thought it was going to be stable in time for this talk, but I'm recording it in advance, so I could have been wrong. But check the chat for an invite link to the Discord bot, and hopefully it's there, and if not, there's some lame excuse from me about why you can't do it. Here's some example Imaginarium code, along with the equivalent code in ASP. I don't have ASP translations of everything, but this, which says a bunch of breeds are kinds of cat, corresponds to this fragment of ASP code. This, which says that cats can be either big or small, but can't be both and don't have to be either, that corresponds to this. All Chartreux are gray corresponds to this, and cats are black, white, gray, or ginger corresponds to this. And then there just wasn't room to have the other stuff. All right, there are a bunch of design commitments in the system. We didn't want people to have to type a command saying this is a noun. Cat is a noun. We wanted you to just be able to start talking about cats and have it figure out from context that it's a noun. We also wanted to let you have compound nouns like global conspiracy without having to separately explain the concepts of global and conspiracy. There's some tension between those two because the first time it sees global conspiracy, it wouldn't necessarily know whether that's one concept or two concepts modifying one another. So we have the rule that the first time you use a concept with this system, it has to be unmodified. The grammar is really simple, and we make sure that any occurrences of user-defined concepts are separated by specific keywords, so there's no ambiguity about where one user-defined phrase ends and another one begins. We designed the knowledge representation language so that when we're in the process of compiling a query down into a SAT problem, we're going to go by way of first-order logic, and so the system needs to know at the time it's grounding things into SAT what all the individuals in the universe of discourse for the first-order theory are. That's not hard to do, but it is something that we did require. And then finally, we did not try and do stable model semantics like there is in ASP. We wanted nice monotonic logic that is more familiar to people, but also more predictable for most people who aren't specialists in non-monotonic logic. Here are some example sentence patterns that it understands. You can give it a list of noun phrases and say they're all kinds of some other noun phrase. You can give it a list of adjectives and say instances of this noun phrase have to have one of these adjectives, things like that. You can say a certain verb implies another verb, or two verbs are mutually exclusive, etc. The data, as you saw, is held in a semantic net. The big things in the semantic net are the common nouns, which are unary predicates, proper nouns, which name individuals, adjectives, which are another kind of unary predicate as far as the logic is concerned, but which gets surfaced differently in the natural language, and then a few other things. Properties are numerical things or string things that the SAT solver doesn't understand, but they get handled by the extra bells and whistles of the SMT solver. It understands part-whole relationships, and you can teach about verbs. Converting it into a SAT problem is relatively easy. Most of the sentence patterns correspond to single horn clauses, but some things like taxonomic constraints are a little more complicated. So if you say a bunch of subtypes are subtypes of a parent type, then you both have to have implications that say being the subtype implies being the parent type, and also have a pseudo-Boolean constraint that says that if you're of the parent type, then you are also of exactly one of the subtypes. All right, we definitely need to do a real user study. There are also a bunch of frequently requested features, such as having statistical control, having control over which nouns are more common than other nouns. There are few random limitations that we want to take away. The big thing is I think we need to have a library of pre-built components that people can put together so that if they're making a character generator for some RPG or for NPCs or something like that, they don't have to reinvent an ontology for character personalities. But then if you're using that pre-built thing, it might not be exactly what you want, or there might even be something in it that you find offensive. So we want to have some kind of language support for being able to, when you import one of those micro theories, override or delete parts of it. All right. Thank you to everybody who gave me helpful advice and encouragement on it, and especially thank you to all the awesome students who helped me build this system. So the good news is it seems like it may really be plausible to build a declarative programming system that you can put in front of naive users. That's fantastic, but we do need to do more user studies on it, and turning this into a real product that could support a real user committee. There's still a lot of work to do for that. All right, thank you very much.